Now that Revit 2025 is out, I want to do an update on voltage drop calculations for the new version of Revit. I previously did a video on calculating voltage drop in Revit. I also did a video on new features in Revit 2025 for electrical engineers, and none of those new features address any of the problems with voltage drop. So the answer I had previously in my video about voltage drop in Revit is the same. In Revit 2025, you don't have the features that you need to calculate voltage drop. I want to show you one more way that Revit falls down on voltage drop, just to demonstrate, again, the problems that you have using the out-of-the-box tools in Revit 2025 and other versions of Revit for voltage drop. I also want to show you how you can do this calculation using ElectroBIM in Revit to get correct voltage drop calculations using your Revit model. So you can see I have a very simple Revit model that I've put together here. It's 5 panels with some loads on the panels so that we can do our voltage drop. And if I pull up this schedule here, this is the voltage drop that Revit calculates. So it's the voltage drop along each of the feeders to each of those panels. And what you can see is that it gives you the voltage drop. So Revit gives you just the voltage drop value in volts. I converted that to the percentage. That's the column on the right-hand side. The percentage is below 2% for each of those feeders. But all of those feeders are in a line. That's a sequential set of panels. And so the total voltage drop down to panel P5 is way above 2%. If you add up those values, you're going to get something that's far beyond the 2%. So Revit will automatically resize your feeders for you if they exceed 2%. But in this case, none of them individually do, and it doesn't take into account the fact that there are actually multiple feeders in line. So the voltage drop value it's giving you isn't actually all that useful, and you can't change these wire sizes to account for the fact that you actually have a voltage drop that exceeds 2% on this cumulative run of feeders. Let's take a look at how we can calculate this voltage drop using ElectroBIM. So I have the single line diagram that I've created in ElectroBIM here, just laying out the panels. Again, this is a sample project, so this is probably not how you would actually lay it out in real life, but I've got the panels inserted there in my drafting view, and I've got my feeder schedule. So these are all 100 amp feeders, and we can go to the voltage drop in ElectroBIM, and you can see that we have the same calculation happening. It's formatted a little bit differently in our software, but you can see the individual voltage drop in the voltage drop column for each of those feeders. It's about 1% in our calculations. You will note that's a little bit different than what Revit was calculating. Don't get too hung up on that. We're calculating it a little bit differently. And for the purposes of this demonstration, I didn't worry about getting those the same. So we have 1% voltage drop to each of the panels, and then you can see the total voltage drop along the whole run from the utility on the far right-hand column. It's about 4%, and you can see the exclamation points there highlighting the fact that it's over the 2% voltage drop that you'd like to see. Next, let's turn on the automatic upsize in ElectroBIM. So we'll change upsize feeders from no to yes, and we will redo our calculations, and you will see that the total voltage drop is going to go down to under 2%, and the voltage drop on each of the feeders is now about 0.5% because you have 4 feeders, and we need to get them all cumulatively below that 2%. You can also see that we have those new wire sizes being listed in this schedule as well. If we go back to the single line diagram, you can see that each of those feeder sizes has also been updated here. If you're using our software for your voltage drop calculations and for your single line diagram, you make a change in one and it's going to update the other. You can see that the feeder schedule also was updated to include those additional wire sizes in it. There's one more schedule I want to show that ElectroBIM includes, and this is our voltage drop upsize review. What this does is it shows you the original wire size that was calculated for each feeder, and then the actual size that's being used, the upsized value. So you can see that originally we had number 1 wires for everything, and those have been upsized to 4/0, 3/0, 250 kc mil, just based upon the length of each of the feeders. This schedule lets you back check the upsizing that the software is doing, so you understand what's happening with your wire sizes. You can see what's changed and make sure that you as the engineer are comfortable with the changes that the software is making on your behalf. So ElectroBIM can calculate your voltage drop using your feeder sizes. It does a lot of other stuff as well. We do the single line diagram as you saw here. We also have fault calculations. We can do arc flash. We can do selective coordination. So a lot of the calculations that you want to see in Revit, ElectroBIM adds for you. You can download a free trial from our website. And of course, if you enjoyed this demonstration, make sure to like the video and subscribe to the channel.